We're now going to answer another exponential inequality question. So you might like to pause the video and see if you can do this one for yourself. I think it's a really great idea to give it a crack before watching me do it. All right, we're now going to jump into it. So we need to solve for x and give values correct to 2 decimal places if necessary. And here we've got 0.4 raised to the x is less than 5. And we're going to do method 1 first. And remember, method 1 involves graphing it. So here I've got 0.4, whoopsie daisy, I've got 0.4 raised to the power of x. Now this is where you have to be careful. I feel like a lot of us, and tell me if you made this mistake, just immediately drew it like this. Well, that's not going to be the case. And the reason why is because that my base is less than 1. So look here. This tells me that if the base is between 0 and 1, I have a reflection occurring in the y-axis. So that means my graph is actually going to look like this. It's going to be y is equal to 0.4 raised to the power of x. We can think about why this is the case. Let's use a simpler example. Let's say I gave you y is equal to a half x. So in this case, I've got an a value that is less than 1. Well, what's another way of writing this? I could write this as 2 raised to the negative 1. That's the same as a half. And as you can see, if I was to do that, I'm going to be left with a negative in front of my x, which tells me to reflect it in the y-axis. So that's the thinking that's going on here. At the end of the day, you need to know that if your base is less than 1, then you're going to have to reflect it across the y-axis. Okay, what else can we say here? Well, we know that this point here is going to be 1, because if I was to let this be equal to 0, any number raised to the power of 0 is going to be 1. Then we're going to put in our other graph, which is 5. So that's going to be here. This is going to be y is equal to 5. Let me do it over here. Y is equal to 5. Okay, now let's read our inequality, but really think about it graphically. What this is saying is, where is 0.4 raised to the power of x? So where is my red graph less than my blue graph? Where's my red graph less than my blue graph? Well, hopefully you can see it's this portion right here. That's where it's less than. So thinking about this, if I can find this point right here, the intersection point, then I can say whenever I'm subbing in x values that are greater than this point right here, I'm going to be less than 5. And let's think about this by subbing in points. If I put in a value here, do you see how I'm going to get a value less than 5 out? But if I put in a value over here, I'm going to get a y value that is greater than 5 out. And I only want things less than 5. Okay, the next step here is we find the intersection point. So step 1 is you find where they intersect. And the way that you do that is you simply go, well, I know that I can't make the bases the same. So we simply say 0.4x is equal to 5. So I set them equal to each other. Then I say x is equal to log of a base of 0.4 of 5. So that means this point right here is log of 0.45. Okay, now once we've done that, the second step is just reading this off and saying, well, that means x has to be greater than, it's not greater than or equal to, it's just greater than log of 0.45. And that is going to be our answer. So one thing I wanted to take note of is see how like the inequality swapped around. Now, we were able to determine that that swap happened by graphing it carefully and taking note of the fact that we had a reflection in our y-axis. You have to be careful. You have to be careful. All right, I'm going to pause here. You might like to try method 2 yourself.